So that's why I'm nervous. So can I tell you what's going on in free space?
Yes, yes.
Formal definition.
Wait, the minimum is 0.5 and 0.1, so you just pick whichever one of those
Is the smallest. Well, in this example, I contrived this example. I made it up out of thin air. It's more just an illustration of how you would generate the delta. So formal definition for all, excuse me, I misspoke. I meant to say the limit of the output of my function f in two variables as a point x comma y approaches the point how about a comma b is equal to L simply means the following. For all epsilon greater than 0. There exists a corresponding delta value that's strictly positive as well, such that the deviation between the output of my function f at x comma y and the point, not the point, the value L is going to be no more than epsilon units whenever my order pair x comma y is no more further away than a comma b than some distance called delta. Shoot, how do I write that mathematical symbols? Oh, I remember. It's the first day class. So distance formula. Whenever the square root of x minus a squared plus y minus b squared is going to be strictly less than delta. Oh, but by the way, you guys, we don't really care what happens at the point a comma b, so I've got a double inequality. I think that is my natural extension of my Math 30 definition, and that is to say epsilon delta definition of the limits. I think this is a corresponding higher dimensional analogy of my epsilon delta definition limits back in Math 30.
So what we're saying here on this last line, so we have some number which is less than epsilon whenever our, what is this quantity in the middle of the two?
This quantity represents the distance between x, y and the point AB. So you can visualize it this way. In the xy coordinate plane, here's the x-axis, here's the y-axis. Oh, I've got some point a comma b is fixed. I just maintain that if I deviate from that point by no more than delta units, then the corresponding z value in the surface at any point above this particular disk is going to deviate from L by no more than epsilon units.
Oh, so we're taking something that was linear and now we're making it two-dimensional.
Absolutely. I'm jumping with one more
So,
dimension of space.
kind of silly question, but is the absolute value just not in there anymore?
I don't need it because when I take the square root of all this garbage, it's always positive.
Well, I know, but you could have a negative on the outside of the square root.
But I won't because I'm using the distance formula.
Okay.
Actually, I'm the one who wrote the square symbol. There's no negative sign on the outside.
Okay,
So it's strictly positive.
okay.
Okay.
Maybe spoke a little bit. It could have been actually equal to 0 if I allowed x and y to be a and b simultaneously.
Yeah.
I'm just not considering that particular case.
Okay.
Anybody else? Yes.
So a consequence of using the distance formula is it traces out a circle?
Well, certainly if I consider any point x comma y no more than delta units away from AB, it definitely is a disk. I'm just not including the boundary points. And what's really interesting, you guys check this out. When you come to class next time, which I plan to do today, when you come to class, to show that the limit doesn't exist, we can just use that idea that back in Math 30, a two-sided limit doesn't exist. The one-sided limits disagree. It's just that now I'm in two-dimensional space here in the board with the domain. It means I got to find two different paths coming to AB, and they may not be linear. They could be quadratic. They could be polynomial. If I can find two paths coming to A, comma B, that give me a different alphabet function, a different result of taking a limit, then I think my limit's not going to exist. I'll be able to prove that I've got a point of discontinuity in the xy coordinate plane.
So two functions, I mean, in what?
I'm just saying this. If I look at what the y values seem to be approaching as I travel on this curve to AB, and what the z values in my surface seem to be approaching traveling on this curve going to a comma b in the xy coordinate plane. If I'm approaching two completely different values, then I know the limit does not exist. Very much analogous to what you said back in Math 30, I'm just dealing with two space as far as the domain is concerned, not one space like you did in Math 30 in terms of domains.
Why are the red and the blue related?
I'm just saying if I come to a comma b two different paths, and I see the y values seem to be approaching a different value, I said y values, I meant z values, seem to be approaching different values, then the limit's not going to exist. But you'll have to find those paths.
Okay.
How many different ways can you approach a single point?
Infinitely many.
Actually,
So you're gonna have to be intelligent in choice.
so you have to basically find what could possibly be.
Give you different values, yes.
Yeah.
That's
And then-
exactly what's going to happen. All right, I've already abused the clock too much. More next time?
You haven't decided
Oh, homework.
You know, I can just tell that I'm gonna be seeing you in your office over this later.
Absolutely.
I can already tell.
Oh, there it is. I thought I lost the book. I can tell you. In section 12.2.
A math-based fraternity, the Epsilon Delta Club. Oh, for physics? Oh, yeah, definitely.
11 through 25 odd.
Here, my friend's waiting for me. The Epsilon Delta, so if you get into
27,
So what section are we in right now?
12.2.
What about 11 through 27 odd?
That's a good question.
I know, I'm just stalling because I'm looking at it.
Okay.
Okay, so what are we doing?
Start over.
12.2 number.
So 11 through 33 odd.
Okay.
34. (42) through 48 all.
Wait, say it again?
42 through 48 all.
We're still in 12.2.
Yes.
57 and 59 look nice. All right, sounds good to me.
What'll the quiz be on Friday?
I can talk enough about it. I'll have to wait till I give you more examples of limits.
So what's the test gonna be on?
Um,